1. Opening ****. Good morning, ladies and gentlemen. Today I am honored to present to you various rail transit vehicles for passenger transport. This presentation will explore different classifications of rail transit vehicles, their applications, and finally highlight examples from Nigeria. Chapter 1, Classification of Rail Transit Vehicles. 2. Power Supply ***. Let us begin with the first classification, power supply. Rail vehicles are powered in two main ways. Some use onboard diesel generators, while others draw electricity directly from ground-based power supply networks. 3. Power layout ***. The second classification is power layout. When the power equipment is concentrated in a single car, we call it centralized power, which creates a locomotive. In contrast, distributed power places traction equipment under multiple cars, making the whole train self-propelled. 4. Running speed ***. The third classification is by speed. Any train running faster than 200 km per hour is considered a high-speed train. These trains are usually streamlined in design to reduce air resistance. Chapter 2, Various Rail Transit Vehicles. 5. Long-Distance Vehicles Overview ***. For long-distance service, we need higher-speed vehicles. These can be electric or diesel-powered, and they may use either distributed or centralized layouts. Examples include the CR400 distributed power EMU and the CR200J concentrated power diesel unit. *6. Distributed power electric EMUs ***. Distributed electric multiple units have excellent acceleration. Their multi-point traction gives strong starting power, great climbing ability, and smoother rides, making them perfect for high-speed and frequent stop service. 7. Distributed power diesel units ***. Diesel multiple units with distributed power are independent of electrified lines. They accelerate better than locomotive-hauled trains but require more complex maintenance, and they tend to be noisier with slightly lower passenger comfort. 8. Concentrated power electric units ***. Concentrated power electric trains resemble locomotive-hauled trains. They are easier to maintain because power is centralized. However, they have weaker acceleration, lower space utilization, and reduced efficiency compared with distributed systems. 9. Concentrated power diesel units ***. Concentrated power diesel multiple units can operate anywhere without electrification. Their maintenance is simple, but their performance is limited by diesel engine power, which makes them slower and less efficient. 10. Short-distance vehicles overview ***. Now let us turn to short-distance vehicles. These trains usually operate at speeds below 160 km per hour. They also come in both electric and diesel versions, and in either distributed or concentrated layouts. 11. Distributed power electric for short distance. Distributed electric trains for short routes offer excellent acceleration and braking. They carry more passengers since almost all cars can seat people, and they provide quiet and comfortable service, but they do require electrified lines. 12. Distributed power diesel for short distance. Distributed diesel trains are highly independent, making them suitable for remote or non-electrified lines. They outperform locomotive-hauled trains in acceleration, but noise, vibration, and maintenance remain challenges. 13. Concentrated power electric for short distance. Concentrated electric trains have weaker acceleration and lower space efficiency since power cars do not carry passengers. However, they are easier to maintain thanks to centralized equipment. 14. Concentrated power diesel for short distance. Finally, short-distance concentrated diesel units can run without electrification. They are noisy, with poorer acceleration, but their centralized design makes maintenance relatively simple. Chapter 3: Various urban rail transit vehicles. 15. High-capacity urban systems. Let us now discuss urban rail systems. First, high-capacity vehicles. These trains often have 6 to 8 cars, sometimes more than 10. They are large, wide, and long, and can carry up to 3,000 passengers, making them suitable for busy city corridors. Infrastructure for high capacity. Such high-capacity systems run at speeds of 35 to 80 km per hour but demand large investments in stations, tracks, power supply, and signaling. This makes them ideal only for cities with very high passenger demand. 17. Medium-capacity urban systems. Medium-capacity urban trains usually have 2 to 4 cars. They are smaller than metros but larger than trams, carrying 600 to 1,200 passengers. They offer flexibility, often using monorail, maglev, or rubber-tired systems. 18. Advantages of medium capacity. These systems can be built underground, elevated, or on the surface. They are cheaper than metro systems, making them suitable for branch lines or medium-demand corridors in large cities. 19. Low-capacity urban systems. The last type is low-capacity systems. These trains are very small, only 1 to 2 cars, sometimes 3. They carry 200 to 400 passengers, ideal for low-demand routes. 20. Applications of low capacity. Their main advantage is flexibility and low cost. They are commonly used in trams, streetcars, modern light rail, and automated people movers such as airport shuttles. Chapter 4: Nigerian Rail Transit Vehicles. 21. Nigeria's rail network. Now, let us focus on Nigeria. Nigeria has a mixed railway system, consisting of 3,505 kilometers of Cape gauge track and 669 kilometers of standard gauge lines. 22. Abuja Rail Mass Transit Overview. The Abuja Rail Mass Transit was Nigeria's first rapid transit system and the second in all of sub-Saharan Africa. It connects the city center to Nnamdi Azikiwe International Airport, stopping at the Edu station along the Abuja-Kaduna line. 23. Importance of Abuja System. This project greatly improves mobility in Abuja, providing residents and travelers with reliable transportation and linking urban transit with intercity rail. 24. Lagos Rail Mass Transit Overview. Next is the Lagos Rail Mass Transit. Lagos, Nigeria's largest city, now has its own urban rail system. 25. Blue and Red Lines. The Blue Line opened on September 4, 2023, followed by the Red Line on October 15, 2024. These lines mark an important milestone for public transport in Nigeria. Closing. 26. Conclusion. In conclusion, we have explored the classification of rail transit vehicles, their differences in long-distance and short-distance applications, and their use in urban settings. Finally, we looked at Nigeria as a case study, where modern rail transit is making impressive progress. Thank you very much for your attention.